2.5 transformations of functions preparation. Use the graph of f of x is equal to the absolute value of x to obtain the graph of g of x is equal to the absolute value of x minus 3 and absolute value plus 1. Okay, so the original one should look something like this. There we go. And this right here. Okay. So that was the original one. Okay, let's see what the new one is. And typo again. Okay, so this should have been the absolute value of x minus 3 and absolute value plus 1. Okay, so positive 3 in here. So I need to break this up again. So I'll break off the negatives up the top, and I'll put the positives on the bottom. All right, and then over here we'll do positive 1, positive 2, positive 3. All right, so if I do a negative 3 minus 9 is negative 6. Absolute value of negative 6 is positive 6. 6 plus 1 is 7. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is positive 5. Positive 5 plus 1 is 6. Negative 1. Negative 1 minus 3 is negative 4. Absolute value of negative 4 is positive 4. Positive 4 plus 1 is 5. And so on and so forth, right? So 0, 0 minus 3, negative 3. Absolute value of negative 3 is positive 3. Positive 3 plus 1 is 4. 1 minus 3 is negative 2. Absolute value of negative 2 is positive 2. Positive 2 plus 1 is 3. And hopefully you see the pattern now. 2 minus 3 is negative 1. Absolute value of negative 1 is positive 1. Positive 1 plus 1 is 2. And 3 minus 3 is 0. 0 plus 1 is 1. So on and so forth. I probably don't have enough points there, but hopefully you kind of get to the point that was being made there. Okay, so let's see what this looks like. So negative 3, 7. So negative 3, positive 7 would be right about there. We would say negative 2, 6. So negative 2, 6 is right there. It's like here, here, here. And if we would have had more points, we would have found this pattern right here. Oops. There we go. So we would have found this pattern right here. Okay, so this just combines the vertical and horizontal movements of the previous one. So in this case, if you just look at the bottom right here, this little point right there. So what happened is, because of the negative 3, it moved 3 to the right, and because of the positive 1 right here, it moved 1, 1 up. Okay, and sure enough, it went up 1, and then it went to the right 3. Which is exactly what you would have predicted, given that, right? So 1 up and to the right 3. And that is the both the vertical and horizontal transformation of that. Okay. Okay, so let me do the original one on this one. Should have looked something like that. There we go. And like that. Okay, so that was the original one. Now, without me actually filling out that chart, let's see if we can figure this out. It's adding 2 here to the x's, so it's opposite looking. So it should go 2 to the left. And because I'm subtracting 3 here, it should go 3 down. So these points should move. Right? There was originally a point. Maybe I should have done the black one first. So there was a point there. There was a point there, there, and there, as well as here, here, and here. So I should just be able to shift those, right? So again, 2 to the left and 3 down. 1, 2, 3. 2 to the left, 1, 2, 3. 1, 2, 3. Now, 1, 2. So 2 to the left and 3 down. 2 to the left, 3 down, 1, 2, 3. To the left, 3 down, 1, 2, 3. To the left, 1, 2, 3 down. 2 to the left, 3 down. Messed up on that one. Let me fix that. Okay. So that little point right there. So, oops. So 2 to the left, 3 down, 2 to the left, 3 down, 2 to the left, and 3 down, and finally 2 to the left, and 3 down. 1, 2, 3. Right there. And yeah, that should do it. So we should be able to draw it, and it should basically be the original, but because of this, it shifted 2 to the left, 2 to the left, and 3 down. And that's what happened.